Hello children. Now in this video we will discuss how to find the distance between two straight lines given. Here the distance is the shortest distance between two lines. Suppose take here is a line given, that is line L1, which is passing through a point A. Let us take another straight line, say this is L2, which is passing through the point B. If we want to find the shortest distance between these two straight lines L1 and L2, we should draw a line which is correctly perpendicular to the another line from the point A. Okay? So if you take any other distance from that point to the line L2, that will be only the distance but not the shortest distance. Clear? Now, to find this, say this is the point C, from A to C. When we draw the perpendicular, this is the shortest distance. Let us take this as small d. To find this, we have a formula. So we are going to discuss how the formula can be used to find the distance between the two straight lines L1 and L2. Now, as we know that the equation of the straight lines are A plus lambda B, A vector plus lambda B vector. R vector is equal to A vector plus lambda B vector. Now we are taking the two straight lines. Let us take the equation of the first straight line is R vector is equal to A1 vector plus lambda B1 vector. Similarly, the equation of the straight line L2 is R vector is equal to A2 vector plus lambda B2 vector. Now we are given two straight lines L1, L2. The equations are given on the board. Now how to find the distance R? Sorry, distance D. First we should find D is equal to the unit normal vector of B1 vector and B2 vector. Unit normal vector means we have to find the cross product of the two vectors and then divide that with the modulus of their cross product. Look at this, B1 vector and B2 vector, they are found cross products, divided by modulus of B1 vector cross B2 vector, and then put a dot, that means dot product with A2 vector minus A1 vector. So here what we have done is D vector is equal to B1 cross B2 dot A2 minus A1 whole divided by modulus of B1 cross B2. Remember, this is the shortest distance. Distance is always positive, so take modulus. Always it is plus or minus. If we get the answer plus, no need of changing it. If it is minus, change it into positive. Always the distance is positive. So, if you are given two equations in vector form, here these two are given in the vector form, then the formula is D vector is equal to D, sorry, not D vector, distance D or the shortest distance D is equal to plus or minus modulus of B1 vector cross B2 vector divided by modulus of B1 vector cross B2 vector dot A2 vector minus A1 vector. This is the formula to find the shortest distance between the two straight lines when their equations are given in vector form. Suppose the equations are given in Cartesian form. Say the first equation is L1 is x minus x1 by A1 is equal to y minus y1 by B1 is equal to z minus z1 by C1. Similarly, L2, another line L2 is equal to, L2 is x minus x2 by A2 is equal to y minus y1 by, sorry, y2 by B2 is equal to z minus z2 by C2. Now, these two are the two straight lines. Same idea. Here the distance d can be found by the difference of the by finding the modulus. The shortest distance can be found by using the formula modulus of x2 minus x1, x2 from the second line minus x1 from the first line, y2 minus y1. That means we are finding the direction ratios of the two lines L1, L2. So Z2 minus Z1. In the second row, we can write the direction ratios which are given in the denominator. So A1, B1, C1. Similarly, from the second line, we can take the direction ratios A2, B2, C2, write them in the third row. Whole divided by square root of A1, B2 minus A2, B1 whole square plus B1, C2 minus B2, C1 whole square plus A1, C2 minus A2, C1 whole square. Using this formula, we can find the shortest distance between two straight lines if their equations are given in Cartesian form. So just now we discussed two different ways of finding the equations of the, just now we found the distance between, shortest distance between two straight lines if they are given in vector form or in the Cartesian form. Now, in some cases, the two equations may be the equations of the parallel lines. If the lines are parallel, suppose say this is one straight line L1, say this is another straight line L2, these two are parallel. It is passing through the point A, this is passing through the point B, but when we are drawing the shortest distance, remember the shortest distance is the perpendicular distance from the point on the straight line L1 to the foot of the perpendicular, that is C is the foot of the perpendicular on L2. So we can take this as small d. Now the equations will be like this: r vector is equal to a1 vector plus lambda b vector. It is not b1 vector because these two are parallel lines. Direction ratios of two parallel lines are always equal. In our previous video we discussed it. So another one, r vector is equal to a2 vector plus lambda b vector. These two are same. Now the formula for finding the shortest distance between the two lines of the two parallel lines will be changed as d is equal to, here this is the parallel vector, so b vector divided by its modulus. Okay, here it is not dot product, it is cross product, a2 minus a1. So our new formula is, if two straight lines are parallel, the shortest distance between the two parallel lines is the perpendicular distance between the two straight lines. The formula is d is equal, it is not a vector, it is only a scalar, it is a value. Shortest distance between the two lines, d is equal to modulus of b vector by modulus of b vector cross a2 minus a1 vectors. In this way, we can find the shortest distance between any two lines. Now, we are going to discuss another concept. Till now, we discussed whether the two straight lines are not parallel. then D value is equal to B1 vector cross B2 vector dot A2 minus A1 divided by modulus of B1 cross B2. So, that formula we learned. And second, if the two lines are parallel, the formula is slightly changed as D is equal to modulus of B vector by modulus of B vector cross A2 minus A1 vectors. Now, in some cases, the lines are not at all meeting each other. Then we should call them as the skew lines or non-coplanar lines. Let us take the 3D plane. Say this is the origin, say this is x-axis, y-axis, z-axis. For our understanding, we can draw this figure. Now, we can name them as a, say A, this is B, this is C, say this is D, this is E, say this is E, F, G, anywhere we can. After locating all these points, all the vertices, we see that when we join this E with a, see, say this line is passing through the vertices E and C. Look carefully, we have joined the opposite corners of a 3D figure. Now, let us join these two corners D and B. Suppose a line is passing through the point D and B. Look at these two lines, they never intersect anywhere, and they are called as skew lines. So, skew lines are the two lines which do not intersect anywhere, and they are also called as non-coplanar lines. So, this is one of the important concepts in 3D geometry. Next, we shall take a problem to find the shortest distance between two lines. Let me take the question. Okay. Suppose two equations are given. Say the line is x plus 1 divided by 7 is equal to y plus 1 by minus 6 is equal to z plus 1 by 1. This is the first equation. Say the second one is x minus 3 by 1 is equal to y minus 5 by minus 2 and is equal to z minus 7 by 1. So, this is the second equation. This is the line 1 and this is line 2. Very simple thing. First you compare the direction ratios of the first line and second line. Here 7 minus 6 1, here 1 minus 2 1. These two are not equal or they are not proportional also. So, remember these two lines are not parallel lines. So, by seeing the two equations and their denominators, that means the B vector, we can guess whether they are parallel lines or not. If they are not parallel lines, we should not go with the second formula. We should go with only the first formula. So, from this, let me take A1 is equal to, here the direction ratio, that is 7, B1 is minus 6, C1 is 1, Similarly, from the second line, we can get A2 is equal to 1, B2 is equal to minus 2, C2 is equal to 1. Okay. Now, let us find B1 vector cross B2 vector. Here we have got B1 vector, this is B2 vector, we have to find their cross product. So, let us take the determinant for I, J, K, write the values 7, minus 6, 1, here it is 1, minus 2, 1. First we should find the cross product of B1 and B2. Expand it, I into the minor of this, that is minus 6 into 1 is minus 6, minus 2 into 1 is minus 2, again it is minus, so it will become plus, minus j, here 7 into 1, 7, minus 1 into 1, it is 1, plus k into, say 7 into minus 2 is minus 14, formula that is minus, 1 into minus 6 is minus 6, it will become plus 6 again. So now when we simplify, it will be minus 4i, it is minus 6j, it is minus 8k. So we have found B1 cross B2, the value is minus 4i, minus 6j, minus 8k. Now we should find B1 cross B2, its magnitude, that means modulus of the B1 cross B2 value. So we will get square root of minus 4 whole square, it is 16, plus minus 6 whole square, that is 36, plus minus 8 whole square, that is 64. When we add them, root of 116. Let it be. So we have found B1 cross B2. Second, we have found modulus of B1 cross B2. Now we need to find A2 minus A1. Here, so already we have found the value B1 cross B2 vectors and the modulus of B1 cross B2. Let me write those values here. B1 vector cross B2 vector is equal to minus 4i vector minus 6j minus 8k. Similarly, modulus of B1 cross B2 is equal to root of 116. Let me rub this one. We need little space for writing the next. So before finding the next things, we can write the formula D vector, we can write D value is equal to modulus of B1 cross B2 vectors by modulus of B1 cross B2. This is the magnitude of B1 cross B2 dot A2 minus A1 vectors. Here we need what is A1 and what is A2. A1 vector can be taken from this L1, line L1. Here these values are x1 value, that is minus 1, y1 that is also minus 1, z1 that is also minus 1, because here it is plus 1 given. As per formula x minus x1, we need x minus x1. Here plus 1 can be changed as minus 1. Similarly, A2 is also taken from the second line, that is 3, 5, here it is 7. We are not changing any sign here because the correct sign is given in the question itself. Let us find A2 minus A1, A2 vector minus A1 vector. So 3 minus of minus 1, that is equal to 4. 5 minus of minus 1, that is equal to 6. 7 minus of minus 1 is equal to 8. We can write this as 4i plus 6j plus 8k. Now, whatever the things we need in the formula, we have got everything. B1 cross B2, A2 minus A1, modulus of B1 cross B2. Let us substitute all the values in the formula. So, D, the shortest distance D, is equal to B1 cross B2, that is minus 4i minus 6j minus 8k. You just find the dot product with this A2 minus A1. So minus 4 into plus 4 will be changed as minus 16, and minus 6 into plus 6, that is minus 36, minus 8 into plus 8, that will become minus 64, divided by root of 116. These all values are in the modulus, because we are finding the shortest distance. Shortest distance is the distance which is not negative. So we will get, when we add the numerator, we get minus 116 divided by root of 116. So when we find under modulus, when we find it, it will be root of 116. The minus value can be removed, because the numerator and denominator both are the same value is 116, but here it is root of 116 into root of 116. One value root of 116 can be cancelled. We will get the final answer root of 116 units. So in this way we can find the shortest distance between any two lines. In short, I will just recollect all the points what we discussed today. The shortest distance between two lines, that two lines may be parallel lines. If they are parallel lines, the formula is D is equal to B vector divided by modulus of B vector cross A2 minus A1. Whereas two lines are not parallel, then the formula is D is equal to modulus of B1 cross B2 dot A2 minus A1 divided by modulus of B1 cross B2. Using these two formulae, we found all the solutions of this topic. So in our next topic, we will discuss how to find the distance from a point to, that means the perpendicular distance from a point to another line, and another one, how to find the image. So you watch, share and comment. Thank you.